All right, ladies and gentlemen, our second buffer problem. So we have the fully protonated form of arginine pictured here. You don't need that for this question. 2 moles of the fully deprotonated form. So I'm going to give you a nice way to start this problem that, kind of gets you settled in. The lowest pKa, which of those is that? pKa1, pKa2. Which one? Which one's the lowest pKa? I didn't ask the question right. That's why I'm not getting answers. Which one's the strongest acid?
This pKa1.
Yeah, and that's the one that corresponds to the fully protonated form, right? Can you remind me when I give you 3 pKas, what the short form was for the generic? H3A. Why don't you, no matter what, do this to start the question as you're reading. The first one, the lowest number is always pKa1, and it's got the most proton. And then the next one, one less proton and one more negative on the chart. So H2A minus. And what about the third one? And when you're done, that should be the last available proton, right? So if I give you 3 pKas, just put your generics down there. And yeah, I don't know where I got -3 because I was talking. Don't talk. HA -2. Thank you. Yeah, it's really good people pay attention. I will make mistakes, and we got to catch them because we want them gone. All right. So in this one, which we don't even have it on the screen. None of those H's is available to start with. How do I know from the question there's no H's available? What magic word in this question says there's no H's available?
That's what I'm looking for.
There's one word that says there's no H's in this species in this question. Fully, 2 words, okay. Fully deprotonated. Fully deprotonated means all the protons are gone. Okay, all the protons that are available. Okay, I'm not saying this molecule doesn't have any hydrogens. Okay, just the ones that are relevant are gone. So give me the generic for the fully deprotonated species, because that's where you're starting in ice number 1. Just don't start it with an H, please. Somebody started A and they said 3-. I love it. How much of that? 2. 2 moles. This is moles. What's it reacting with? HCl. Yeah, there's no spectator there. But there will be a spectator at the end. What does HCl become when it loses an H plus? Loses H plus, proton. Cl minus, comment, who cares? Cl minus will not affect any pH problems because it's a terrible base. But more importantly, what did A3 minus become?
H8 minus?
Yes. She said HA2 minus. So HCl, we started with how much?
3.
3 moles, and I'm getting weird stuff. Security time. Okay. 3 moles HCl. That's the excess reactant. You can only react how much in this problem? 2, because A3 minus is the limiting. And we're going to go +2 on here. There's your new ice problem. We're only doing 2 ice problems this time. You happy?
Yeah.
I won't make you do 3 every time, We got HA2 negative to start with. Plus HCl. Cl minus, who cares? And what species does HA2 negative become when it picks up a new proton from a strong acid? H2A minus. Yes. H2A minus. And you started with 2 moles of that guy and only 1 mole of HCl. Ah. Now, who cares? I'm just going to carry on with it. Who cares?
Why do we put 2 if it was 0 or not? Oh, wait, never mind.
There you go. She got it. So you can't react 2 moles this time. How much can you react?
1.
Yeah, because and you put a happy face here. Why you put a happy face? The strong acid is is gone, is used, is over. Oh, this is a perfect buffer. Do you know how I know?
Is there equal?
Equal amounts of the acid and the conjugate base. Which of these two that I circled in this buffer pair is the acid? They both have protons. You must be careful. Which one is the acid in this pair?
On the right?
The one on the right. Is that pKa1 or pKa2? And you're going to say, Dr. Whitaker, you need the minus sign. You know what happened? My circle looks like it got attached to my minus sign. Sorry. H2A minus. There you go. And pH equals which of the pKa's? pKa2. H3A is pKa1. HA minus 2 is pKa3. This one's pKa2, which is 9.0. Equals the answer, E. And the name of this kind of buffer? There's two ways you can name it. It's a perfect amount of each. It's a perfect buffer. It's an ideal amount of each. It's an ideal buffer. It can neutralize equal amounts of acid or base, right? If I add an acid to this buffer, it will start reacting with this base. If I add a base to this buffer, it'll start reacting with this acid, and it has equal ability to neutralize either one. That is a perfect buffer. And the last question I'm going to do right here, I know it's not even on the screen, it's to tell me which pKa goes on what part of this molecule. I hope you narrowed it down to the lowest number being Z and higher numbers being X and Y, based on what you know already. Carboxylic acids have lower pKa's than any ammonium species. So far you got it narrowed down to the Z better be the lowest number, 2.2. And that narrows it down to choices where, oh, we don't have the choices here, they're on the previous page. Ending with 2.2. We had a blank page, I'm sorry. We have apparently a lot of blank pages. There we go. What am I looking for? Yeah, XYZ. XYZ, so we want Z to be the lowest. We got it down to the last two. Okay? Z is, I shouldn't put that there because people will say, what's that square doing there? All of a sudden it's random. I'm snipping. And we're going on over here.
But it says increasing the acidity chart.
Oh, wait, oh, see, and yeah. Does the question say in order of increasing acidity?
Yeah.
I don't word questions like that anymore. I apologize. But yeah, increasing acidity, 2.2 is the most acidic, right? Or 2, is it 2.2? Yeah, we got the same typo here too. 3. So most acidic should be at the end. Increasing acidity, right? Z should be at the end. So we're down to A or C, correct? Just from our knowledge of acids and bases. Now, the only thing we're comparing here is these two species. I got a nitrogen with a double bond to carbon on one and a plus charge versus a nitrogen with 3 bonds to H. I'm going to reword the question. Which is more stable?
The one on the left?
She's counting bonds and stuff. Don't count bonds. Hybridizations, please. Gives the whole answer. Nitrogen on the left. 3 sigmas, no lone pairs. What do you got?
We have
No,
65.
give me the name of the hybridization. SP2. What's the name of the hybridization? 4 sigmas, no lone pairs. Which one has orbitals closer to the nucleus? 33% S. Orbitals are closer to the nucleus. 25% S. Orbitals further from nucleus.
So the one on the left.
No. This also means plus charge is closer to the nucleus. Oh. That goes over here. Is closer to the nucleus. Are you happy to hear that? Is that a good situation? What's in the nucleus? There's only two things. Protons, what charge? Positive. Is it good to have positive near positive? I find it repulsive myself. And you would too if you were a plus charge getting close to a nucleus. I'm out of here. Give that proton away. Get it out of here. Too close to the plus, too close to the nucleus. Get it out of here. What's that mean? Stronger acid or weaker? Get it out of here. I don't want it. Put it anywhere. It means you're more reactive.
Yeah.
More reactive. More reactive does not mean weak. It's the opposite. Strong. Strong means more reactive. They are literally the same thing. So, okay. Closer to the nucleus. Repulsive. Wants to lose H plus more than this. When you're a stronger acid, is it a lower pKa or higher? Lower pKa means stronger acid. Lower pKb means stronger base. Lower pKeq means equilibrium goes more that way, to the right. Sorry, backward screen thing, to the right. Okay. All right. So, unstable means reactive. When we're talking acids, lower pKa. Stable means less reactive, means higher pKa. Make sense? Stable means less reactive, means higher pKa. Okay? So the one with the double bond has the lower pKa and it's more acidic. So I want the one more acidic for the, I don't even have my choices anymore. Finding that picture's been a nightmare too. So let's just put the numbers down. 2.2, 9.0, 12.5. I've assigned them correctly. You're going to be confused because this was done on an earlier document, but so put them in order of increasing acidity. Most acidic is Z.
I thought carboxylic acid was 5.
It is. But when you have amino acids, there's an influence of an ammonium group being so close to the carboxylic acid that it lowers the pKa for a carboxylic acid. Don't have to know that yet. That's a Chem 242 thing. Any amino acid problem, I tell you the pKa, so you don't have to worry about, I thought it was a different number, because I'm telling you, yes, it is a different number. Do you know how to use my number? Right? That's what this is about.
Honestly, I like amino acid problems because you give us the pKa.
Yeah, I know. It's one less thing to memorize. Yeah. So most acidic and the highest number is the least acidic. I got to write it this way so I can answer this question in an order that I'm not usually asking it. So, and we're supposed to go from order of increasing acidity. So Z is the most acidic, it's at the end. Y is at the beginning, and X must be in the middle, right? Y less than X less than Z, it is C. Very rare for me to have C. I know what you guys do with multiple choice. If you guessed all C on a test, you're most likely gonna get 0. Because I know. All right, so we're there. Hey, that's on video for the first time.